Coming to the next contradiction of space inflation or expanding universe. This structure, as we studied, it was during the times when the universe was considered as static. That universe was not expanding. Life is as it is. At max, it may come back. So you take either Newton's theorem or Einstein's theorem. This is how it looks like. The influence is with respect to the static universe. But thanks to Hubble's observations, which was during the stage of Einstein also, it was observed that all the masses in the space, you take any galaxy, they were all moving away from each other, which suggested that the universe is expanding. And we will see that they are expanding and accelerating, but for the moment we will just consider the expansion of the universe. It was expanding to an extent of 70 kilometers per second. In the sense, if you see a galaxy Andromeda, if it is coming towards us, it is fine. The galaxies which are moving away, they were moving at around 74 kilometers per second, or around 70 kilometers per second. So how do these theorems hold when the universe itself is expanding? Let us see one by one. This is a classic example suggested to explain how the universe is expanding. You have a balloon. You have these three dots, the galaxies, which are three dots. When you fill air, the balloon size increases, and you will see that these galaxies also are moving away from each other. The distance is increasing from each other. But you may have observed the distance increases, though here it is seen as a bigger galaxy than the original one. It does not happen in real life. Galaxies may move away from each other, but the galaxy size itself does not increase. The distance between two stars does not increase. You take the solar system, even if the space within this is expanding, the planets do not go further and further. The size of the solar system remains the same. So let us see how this becomes a contradiction. That is how we have a system wherein you have a central massive mass and all these small planets are going around. For the sake of ease of comprehension, let us just consider Sun and one planet. So you have a Sun, and this planet is at a distance d, and they are able to have this kind of a influence, which we call it as gravity. Space inflates and moves these galaxies. For sure, it can move these two masses away. They both can move in different directions, but let us just assume for a moment that only this mass moves. When these galaxies can move, this mass can also move. Consider for a moment that it is moving. When you move this M2 to this place, the distance that was d has become larger, and obviously when you have the same masses and the distance is increasing, the influence is weakening. So the gravity which was stronger here is becoming weaker here. No, it does not happen that way. This mass is not moving. The planets are there where they are, even if the space is expanding. So I need to bring it back to its original place. If I have to bring it back, the only way is this influence has to increase. How do I influence this? How do I increase the influence? Either reduce the size of this mass or increase the size of the central massive mass. Is that possible? Even if Sun puffs up, the idea is not puffing up. You have to add more mass. If Sun was weighing 1 kg, it should become 2 kg because it has to bring it back. So this is how we see. G is equal to m1 m2 by d square. So when you move, you increase the distance, the gravity is reducing. When you want to bring this d back to d, this has to increase or this has to decrease to bring back the gravity. That does not happen so. This is the contradiction. So this is possibly why the gravity does not exist. When we consider the Einstein's theorem, it's exactly the same. The farther the mass, lesser is the influence. So we have a massive planet, massive mass, smaller planet, you have a gradient because of the bending of space. As I said, the space inflation moves the galaxies. Obviously, it should be able to move this mass. Let's consider for a moment that these masses move. So the steeper gradient becomes a gentler gradient. Planets do not move, we have not seen them moving, so I have to bring back the planet to its original position, which means this gentler gradient has to be made steeper gradient. That is possible only when I increase the mass of the central body or the sun, which does not happen. So that's why we say, even with Einstein's theorem, gravity does not exist, or the way it behaves. So the next contradiction was that earlier the expectation was that the universe is static, but later on when it was realized that it was expanding universe and hence the space itself was inflating. To begin with, they said that it is the gravity which is holding all these planets together in a static universe. It was also said that when the space inflates, the distance between the masses may increase, but the size of the galaxy itself does not increase. Size of the planet also does not increase, because again it is the gravity which is holding back. So when we combined these two cases, so the first one was the static universe wherein you had this planet here. So when you go to the next expanding universe, when the space, when it is inflating, when it can move the galaxies, it could move the masses also, the planet also. When mass is moved away, the sun has to bring it back, and that can be brought back only when the primary mass is increased or the secondary mass is decreased, and nothing like that happens. And it is a continuous expansion, so you cannot be adding on masses to the sun, and plus where do we get the mass to add to sun in the solar system? There is nothing. And it is the same when you consider the Einstein's theorem. Now, how does Spacity explain this contradiction? How does it keep these masses in position? Now see this, when it was static universe, when the space tried to move it, it could move because there is nothing, no force stopping it. But in case of Spacity, we have S2, which is acting from outside, an external force, plus the mandate of the Spacity itself, that it has to keep the masses in the system, whether it is static, motion, whatever. So this mandate is missing in gravity, and hence in the classical model of universe, and hence you are not able to explain it. But this Spacity beautifully explains it. And what is true for a sun and a planet is true for the stars in a galaxy also.